This lesson focuses on solving linear equations and inequalities. They're going to be very similar in how we solve them. Just for the inequalities, we have a little extra to consider. So first of all, a linear equation in one variable is an equation with a variable to the first power, x to the first, which we just write x, that is not in the denominator or a root or in an exponent. So here we have some examples of linear equations. So you can take a look at those. Notice that they have just one variable, and the variable is to the first power. In the nonlinear equations, notice that they fit one of the other situations that was mentioned that was not a linear equation. So in the first one, there is a variable under a root. In the second one, there's two problems here. First of all, x is not to the first power, and second of all, it is in the denominator. And in the third one, you have a variable in the exponent. So those are not linear equations. Here's several properties of equality that you have learned in the past, and here's a review. So we have the property of addition, the addition property of equality. If you add the same quantity to both sides of an equation, the equation still remains true. So you see it there as an example with numbers, and then you see it with variables, where a, b, and c are just real numbers in that case. Subtraction really is tagging off the addition, because subtraction we think of as the same as adding the opposite. So same idea, same principle, you can subtract the same thing from both sides of an equation. Multiplication, if you multiply the same quantity to both sides of an equation, the equation will still be true. So here we see that 3 is equal to 3. If we multiply both sides by 2, we get something that's also true. And same thing over here with the variables. A is equal to b, so one quantity is equal to another. We can multiply both sides by the same quantity. Dividing really is very similar to multiplication, because multiplying and dividing are inverses, so they have pretty much the same rule. You just have to be careful, because we can't divide by 0, so you have to divide by the same non-zero quantity, because we can't divide by 0. So all of these together are basically saying what you do to one side of an equation, you must do to the other side of the equation. We have to keep those equations balanced. So here's several examples that you should be able to do. The first thing we're going to do when we solve these equations is simplify each side of the equation if necessary. There are different ways to go about this, but that's going to be probably the most straightforward way. So over here, first we're going to distribute this 4, and so we have 4m plus 48 is equal to negative 36. And then we're going to use our properties of equality. Here we see that 48 is added to the term with the variable, so we're going to subtract 48. And when we do that, we're left with 4m equals negative 84. And then dividing both sides by 4, we get m is equal to negative 21. And we could go back and check that, plugging m back, or negative 21 back in for m. Negative 21 plus 12 is negative 9. And we do know that 4 times negative 9 is negative 36, so that's correct. This one we could do pretty much the same way. So we could distribute and then solve, and you definitely can do it that way, and that's what we'll normally do. I just want to show you something else. Here we have our variable in here, so if we think about it, we want to get rid of this 3 first. Well, this 3 is multiplied by what's in parentheses, so what we can do is divide both sides by 3, and we would be left with 2 minus 3p equals 14. And now we're down to solving, so we could subtract 2 from both sides. Negative 3p equals 12. And dividing by negative 3, gives us p is negative 4. So you could also do that as long as you work through your order of operations. You really do it in the reverse order of operations. But again, just if you don't prefer that way, or that was confusing or new, first of all, you could look through it again and go back through that. Just watch that again, or you can remember we can distribute, and we get 6 minus 9p equals 42. We could subtract 6 from both sides. We get negative 9p equals 36, and dividing both sides by negative 9, we still get that same solution of negative 4. So you can do it either way. Again, we usually do it that second way. On this next example, once again, what we're going to do is try to simplify the left side and simplify the right side, and then work between sides. So notice we have, in this case, a variable on each side of the equation. Over on the left side, we see we have a 3k and a minus 14k, so that's negative 11k. Plus 25 is equal to, and here we have some like terms, 2 and negative 12, which is negative 10, minus 6k. Notice we don't do anything between sides yet. We worked with the left side, simplified that, worked with the right side, simplified that. And now that we've done that, maybe we can, or we will, work between sides. So our goal is to solve for k, and to solve for k, we need to have anything that has k as a part of it on one side. So what I'm going to do, I'm going to go ahead and add 6k to both sides. I'm doing the inverse of minus 6k, so I'm adding 6k to both sides. Doing that leaves me with a negative 5k plus 25 on the left, and over here those become 0, and you have negative 10. And now again we want to solve for that k, so we'll go ahead and subtract 25 from both sides. Subtracting 25 from both sides gives us negative 5k is equal to negative 35. And then finishing it off, we can divide both sides by negative 5. And when we divide by negative 5, we get k is equal to 7, because negative 35 divided by negative 5 is a positive 7. And again, we could go ahead and check that solution by plugging it back into the original, and it will work out correctly. The left side would equal the right side. Something we don't really see much in Algebra 1, it's a little newer to Algebra 2, although you may have seen it, is when you get identities and contradictions. An identity, if you're going through a problem and solve an equation, an identity is an equation that's true for all values of x. So when you solve something, the way that you would know it's an identity is when solving it will come down to something that is always true, such as like 5 is equal to 5. That's something that's definitely true. It's always true. A contradiction is another case where there's actually no solutions. And that will happen when solving it will come down to something that's false. And so, for example, you might see something that negative 3 is equal to 7, and that's definitely false. So that would mean that that equation has no solutions to it. So let's go ahead and look at these two examples. Maybe we'll come across an identity or a contradiction. So looking at this first one, we're going to simplify each side first. So I'm going to look at the left side. I have a 3v and a minus 4v, which is a negative 1v, or just negative v, minus 9 equals, and then over on the right side, this negative can be distributed, or we think it's the opposite of what's ever inside the parentheses, so that's negative 5 minus v. Next, we might think, I don't want this v over here on the right side. I want to solve for v, so let's go ahead and add v to both sides to get rid of that. And we get, over here we just get negative 9 because this becomes 0, and over here we get negative 5 because this becomes 0, and so this is a case that we mentioned is a contradiction. So we came down to something that's false, so there's no solution, which means there is no value of v that can ever make that equation true. There's no number we can put in there that will make that equation true. Coming to the next one, we can simplify each side of this. So on the left side, we can distribute, and we get 2x minus 12. On the right side, we have some like terms. 5x plus 7x is 12x. $12x minus 12. To solve this, we might think, okay, well, I want to get all my x's on the same side. And maybe some of you like always to be negative or always to be positive, so you could subtract 2x from both sides, which would give us a positive 10x on this side. Minus 12 equals negative 12. And then we could add 12 to both sides. And we get 10x is equal to 0. Dividing both sides by 10, we get that x is equal to 0. And so this one does have a solution. Don't get confused here. Some people get confused or upset if they have a 0 on the left side. 0 is still a number, so when we get negative 12 minus 12, it's 0, and you can continue to solve. Another thing we can think about this equation, thinking back to what it actually means, 10 times what number equals 0? Well, 10 times 0 equals 0. So this has a solution, and it is 0. Now we're going to just quickly investigate linear inequalities. And so we're going to try to figure out some rules here, and these are most likely familiar to you because they're studying Algebra 1. Use the inequality 2 is less than 10, so hopefully we all agree that 2 is less than 10, to fill in the table below. So 2 is less than 10. Let's add 7 to both sides. So we're adding the same thing to both sides. So these are going to be similar to what we mentioned before. So add 7 to both sides, you get 9 is less than 17. Add negative 4 to both sides. Oh, by the way, and 9 is less than 17, that's still true. Add negative 4 to both sides, you get 5 is less than, sorry, I need to look back at the original. So negative 2 is less than 6. That's still true. Multiply both sides by 3. Multiplying both sides by 3 would give us 2 times 3 is 6, and 10 times 3 is 30. 6 is less than 30, so that works. Multiplying both sides by negative 4. So 2 times negative 4 is negative 8. 10 times negative 4 is negative 40. This, however, is not true. A negative 8 is not less than negative 40. This is false. And so what hopefully we can realize here or remember from before, that you can add or subtract anything from an inequality, from both sides of the equality, inequality still stays true. You can multiply or divide both sides by a positive and the inequality remains true. But or if you multiply or divide both sides by a negative, you must switch the inequality sign to make the inequality true. So when multiplying both sides by negative 4, we would have negative 8 and negative 40, but we would have had to realize we have to switch the sign. So when solving inequalities, we must realize that if we multiply or divide by a negative, we have to switch the inequality sign. So here's a summary of that. The addition-subtraction property of inequality kind of goes together. If you add or subtract the same quantity to both sides of an inequality, the inequality will still be true. So you notice that here. We put a part 1 here for multiplication and division. If you multiply or divide both sides by the same positive number, the inequality is still true. So that holds true. But part 2, if you multiply or divide by a negative, the inequality sign must be switched. So when we multiply both sides here by -2, the less than sign got switched to a greater than sign. So let's go ahead and solve this example here. It's an inequality. It's really basically the same as solving an equation. We just have to remember if we multiply or divide by a negative, we have to change the direction of the inequality sign. And that's when we multiply or divide both sides by a negative. So we are going to distribute this -3. -6x plus 15 is greater than 27. So we didn't multiply or divide both sides by a negative, so we don't switch the sign. Now we're going to subtract 15 from both sides. Sign stays the same because we're just subtracting from both sides. So -6x is still, we use the greater than sign, greater than 12. And now we're dividing by a -6. So this is when the alarm goes off. We're dividing by negative. So if we divide or multiply by a negative, we've got to switch this inequality sign. So it was a greater than, we're switching to a less than. 12 divided by -6 is -2. Now the directions said solve n graph. So what we're going to do is we're going to sketch a number line. Here's 0. We'll put -2 over here. And we want to graph x is less than -2. So we want all values less than -2. Well, that's to the left of -2. So what we do, we put a circle around -2 because that's the point we're dealing with. This also should be reviewed, but since there's not an or equal to sign on there, there's not a line underneath, this stays open because -2 is not part of the solution. And then we want to highlight everything to the left, or everything less than -2. And we're going to go ahead and bold this arrow to show that that continues. And so here is the solution. It's saying any value that's less than -2 will work in here. So we could put -3, -4, -10. We could even put -2.013 would make it true. So anything to the left of 2. So that is solving linear equations and inequality.